It's my introduction to AWS D1.1 Structural Steel Welding Code, Part 2. In this one, we're going to get into general requirements and just briefly into design of welded connections. I'm not a structural engineer, so we'll talk a little bit about Clause 2, but we're not going to do a deep dive into it. I'm not technically competent to talk about the structural design elements and cyclical loading conditions or any of that. So we'll just talk about it just very little and we'll skip over it for the most part. We'll acknowledge it's there, but there's people that are much more technically savvy than I am that should probably cover this clause. So we're going to hit general requirements and design of welded connections. Acknowledgments. I borrowed this from the Nuclear Regulatory Commission. They've got a Introduction to Welding Technology and Codes course that's online if you want to go find it. There's some material there that is useful. This one is ML12157A587. It's in a PDF form, so you might have to do some trickery to get it into a PowerPoint presentation, but it can be done. If you type in that ML number into Google and grind through it and throw in Nuclear Regulatory Commission, it should take you to a bunch of PowerPoint presentations that are in PDF format. Also, the Can Teach Canadian deuterium, uranium reactor people, they've got some material on welding that I borrowed. It's all in the public domain. There's a website for it. And also the U.S. Army TM-9-237 welding theory and application. I use that one quite a bit too. There's some good little pictures in there and some very pertinent information about various welding processes. Here's the table of contents, I guess, for my series on AWS D1.1, or I guess this would be the table of contents from D1.1. We're just going to hit Clause 1 and Clause 2 today, and it's probably going to be long enough. We're going to cover general requirements and then design of welded connections. And as I said, design of welded connections is going to be a drive-by. We're going to just briefly talk about it. Maybe I'll talk about a couple of paragraphs in there and some wording. Other than that, I'm not a structural engineer and I don't dabble in the design of welded connections or structural connections. That's not my zone of the universe. So I'll leave that to people that are much more qualified than myself to discuss it. So once again, we'll do general requirements and design of welded connections. General requirements. 1.1 Scope. This code contains the requirements for fabricating and erecting welded steel structures. When this code is stipulated in contract documents, conformance with all provisions of the code shall be required, except for those provisions that the engineer or contract document specifically modifies or exempts. So that's telling us that we're welding steel structures. We're not doing bridges, we're not doing pipelines, we're not doing pressure piping, none of that. We're doing steel structures. Something similar to this picture we've got right next to us. I don't know what it is, but it was on the copyright free zone of the internet, so I tagged it and stuck it in here. But that would be a prime example of, a structure. It's just a structure. There's no piping there. We're not sending water through it. We're not driving cars across it. It's just a structure, a building, structural steel. The code was specifically developed for welded steel structures that utilize carbon or low alloy steels that are 1/8 of an inch or thicker with a minimum specified yield strength of 100 KSI or less. The code may be suitable to govern structural fabrications outside the scope of the intended purpose. However, the engineer should evaluate such suitability and, based upon such evaluations, incorporate into contract documents any necessary changes to code requirements to address the specific requirements of the application that is outside the scope of the code. The Structural Welding Committee does encourage the engineer to consider the applicability of other AWS D1 codes for applications involving aluminum, sheet steel equal to or less than 3/16 of an inch thick, AWS D1.3 steel, AWS D1.4, and stainless steel, AWS D1.6. The AASHTO AWS D1.5 bridge welding code was specifically developed for welding highway bridge components and is recommended for those applications. So what this is telling the universe in general is, hey, AWS D1.1 is a code that is very specific for a certain set of criteria. Low carbon steels that are 1/8 of an inch thick or thicker. It's got a minimum yield strength of 100 KSI or less, so you can't use it on really thin material. Anything less than 1/8 of an inch, you can't use it. If the material's got a yield strength greater than 100 KSI, you can't use it. If you're building a bridge, you shouldn't use it. If you're using aluminum, this one doesn't work. Sheet steel, equal or less than 3/16 of an inch, you should use D1.3. If you're doing reinforcing steel in concrete, use D1.4. And if you're using stainless steel, use D1.6. D1.5 is for bridges. So I've dealt with a lot of engineers in the past, and they just assume that there's one welding code. Well, weld it to D1.1. Well, you know, you're telling me to weld it to a set of rules that doesn't work. It's like telling me to go play baseball with, you know, rugby equipment and the rules to rugby. It's not going to work. So that's why you do need to understand the scope and the limitations of the code that you are working to. And right here, it tells you the limitations. It tells you what this code is for and what this code is not for. Limitations. I'm going to rehash this again. Structural Welding Committee encourages the engineer to consider the applicability of other D1.1 codes. Basically, aluminum, use another code. Sheet metal, sheet steel, stainless steel, reinforcing bar, or bridges. You got to use other codes. AWS D1.1 is not the all-encompassing welding code. I've dealt with mechanical engineers in the past that thought, well, it's the welding code. Weld it. Like it's an all-encompassing code that covers everything from welding a broken heart to the crack of dawn. No, this does not cover that. It is strictly for structures, buildings. It's not for driving cars across or anything that's road-based or with rebar. No, this is a structural steel welding code. And as an engineer, you need to understand that, or a designer, or anybody dealing with this code. Like the previous paragraph states, AWS D1.1 is not the end-all be-all of welding situations. AWS D1.1 is written for welding of structural steels. Other codes are more appropriate for other metals and design criteria. Definitions. The welding terms used in this code shall be interpreted in conformance with the definitions given in the latest edition of AWS A3.0, Standard Welding Terms and Definitions, supplemented by Annex K of this code and the following definitions. This is telling us that AWS 3.0 is basically the dictionary that we're going to use when interpreting and asking for the definitions. So the AWS, American Welding Society, has another book, AWS 3.0, Standard Welding Terms and Definitions. It's, I want to say 100 and some, maybe 200 pages, and it's just basically a dictionary with all the welding terms. And if there's any question about how that term should be interpreted or whether or not you're in conformance, get a copy of that book, look up the definition, and it'll set you straight and on the right path. 1.3.1, Engineer, term and definition. Engineer shall be defined as the duly designated individual who acts for and in behalf of the owner on all matters within the scope of the code. So you're going to see this term quite a bit. The engineer, the engineer, the engineer. So that's what it is. They are the duly designated individual. Under this code, the engineer has a lot of power to do things in regards to what they want. Because I've dealt with inspectors that say, well, you can't do this. It's against the code. And I always tell them, no, you read in there, the engineer can do whatever they want. As long as they document it and they have calculations that say, hey, this is why I'm doing it. They can do what they want. But it's also within their responsibility. They're the one that's going to be getting in trouble if something goes sideways or if there's some catastrophic disaster. But the engineer has quite a bit of power under this code, and that's why we see this term, engineer. 1.3.6 code terms, shall, should, and may. The code terms shall, should, and may have the following significance. 1.3.6.1, shall. Code provisions that use shall are mandatory unless specifically modified in contract documents by the engineer. 1.3.6.2, should. The word should is used to recommend practices that are considered beneficial but are not requirements. 1.3.6.3, may. The word may in a provision allows the use of optional procedures or practices that can be used as an alternative or supplement to code requirements. Those optional procedures that require the engineer's approval shall either be specified in the contract documents or require the engineer's approval. The contractor may use any option without the engineer's approval when the code does not specify that the engineer's approval shall be required. Okay, so we get to shall. Let's start with shall. Shall means you are going to do it. Shall means there's no way out of it. If it says you shall, there's no arguing it. Unless you can get the engineer to change something, or the engineer has specifically modified something in the contract documents to get you out of having to do that, whatever that provision is. Shall means you are going to do it. There's no getting out of it. Should is not quite as great as shall in forcing you to do something, but should, when it says should, it's a pretty good idea to do this. You should means it'll be a really, really good idea to do this, but it's not required. You can get out of it for some reason, and you don't need the engineer to get you out of it. If it says should, I'm not doing it. We realize we should do it, but we're not going to do it for this reason. We've got it under control. The word should. May, it's optional. So, you got a lot of leeway with the word may. And if the engineer wants something in the code to be shall, he's got to go back and modify it to get it to say shall. There in the bottom where it says, the contractor may use any option without the engineer's approval when the code does not specify that the engineer's approval shall be required. So that's in the may zone of the universe, where the contractor can use may. But these are three words that can either save you or sink you. And you need to really understand how they're utilized in the code. And obviously, they put them here and they explained them in very excruciating detail because it is important. A lot of arguments in regards to code boil down to these three words. And if you can find these three words in the code and say, I'm not doing it because it says I should or I may, I'm not doing it. Or if you want the contractor to do something, all right, you shall do it because it says right here, you shall do it. So anyways, I know we're splitting hairs on those three words, but those three words are very important. 1.4.1, Engineer's Responsibilities. The engineer shall be responsible for the development of contract documents that govern products or structural assemblies produced under this code. The engineer may add to, delete from, or otherwise modify the requirements of this code to meet the particular requirements of a specific structure. All requirements that modify this code shall be incorporated in the contract documents. The engineer shall determine the suitability of all joint details to be used in a welded assembly. So that's telling us the engineer's got a lot of stroke, a lot of power in regards to what he's doing. Because the people that wrote this code realized that they don't have the answers to every structure, everywhere, every configuration that's going to be built. They give you a general set of rules, and then they say to the engineer, you can change this, you just need to document it. The engineer can add to or delete from or otherwise modify the requirements of this code. The engineer can do what they want as long as they document it, which generally a good engineer is going to do anyways. So if there's a certain part of the code that the engineer doesn't think is applicable, they can just say, no, we're not following these requirements. We've looked at it. We've analyzed it. Our best practices say that we don't need to do this. We can do this. So the engineer's got a hell of a lot of responsibility. And I've had arguments with people before. Well, it says in the code you can't do this. But yeah, the engineer came back and said, yeah, we looked at that. We're not going to do that. We're going to do it this way. So that really bothers a lot of inspectors because they think they're the code masters. And it gets back to this one paragraph. The engineer can do what the hell they want. You know, as long as they keep the calculations and they're the ones stamping it and they're modifying it and they're documenting it, that's the engineer's rights and responsibilities. The engineer can do what they want. So they're not completely boxed in by the code. So, and it says, you know, the last line, the engineer shall determine the suitability of all joint details to be used in a welded assembly. That's on them. They shall determine it. You know, the engineer needs to look at it and make sure everything's good to go. The engineer shall specify in contract documents as necessary and as applicable the following. The code requirements that are applicable only when specified by the engineer. All additional NDT that is not specifically addressed in the code. Verification inspection when required by the engineer. Weld acceptance criteria other than that specified in Clause 6. CVN toughness criteria for weld metal, base metal, and or HAZ when required. For non-tubular applications, whether the structure is statically or cyclically loaded. All additional requirements that are not specifically addressed in the code. And for OEM applications, the responsibilities of the parties involved. So that's telling us, hey, this is what the engineer is responsible for putting into the contract documents. Code requirements. Number 2 is a big one because if the engineer wants additional non-destructive testing, that they looked at their joint configurations and they see that they need more non-destructive testing, they'll throw it into the contract documents. Okay, we want this much. We think that this is an ultra-critical weld. We need it ultrasounded, dye penetrant, mag particle, everything. We want all the NDT processes done on this specific set of joints. They would address that in the code or in the contract documents, excuse me. Verification inspection, weld inspection criteria. Let's say they have some kind of ultra super critical, one of a kind welds that's going to be made. The engineer would put it in the contract documents that says, hey, this weld or these 7 welds, they need just to be absolutely perfect, and this is my inspection criteria for it. They're also going to tell you whether there's toughness criteria involved. Impact properties. Steel, carbon steel isn't going to react the same in, you know, let's say Midland, Texas, where it never gets, you know, down to minus 45 degrees, or if you've got something up in, you know, northern Alberta in the tar sands where it's just ungodly cold for 5 months. And regular carbon steel will break like glass at 50 below. So they're the ones that make these decisions. Hey, I don't need impact toughness. This structure is going to be down in Florida at 55 or is the lowest it's ever going to see. It's not going to go below that ductile to brittle transition temperature. Or, hey, we need everything to have impact testing done. This thing's going up into, you know, the Yukon territories or northern Alberta, and it's going to be under a significant load, and it's going to be cold, and there's, you know, possibility that toughness issues could come into play. That's where number 5 comes in. And then it's the engineer there's ones that are going to tell you whether the structure is statically or cyclically loaded. So, and then number 7 is a catch-all. Any additional requirements that are not specifically addressed in the code. Anything else the engineer wants done, they're going to throw it in there under number 7. Contractor's responsibilities. The contractor's responsibilities shall be responsible for the WPS's qualification of welding personnel, the contractor's inspection, and performing work in conformance with the requirements of the code and the contract documents. So that's what the contractor's job is. He's responsible for writing the WPS, qualifying the welding personnel, the contractor's inspection, doing his inspection, and then performing the work in conformance with the requirements of the code and the contract documents. So that lays it all out. You know, what his job is. We know it, we got the engineer's responsibilities, now we got the contractor's responsibilities. Approval. All references to the need for approval shall be interpreted to mean approval by the authority having jurisdiction or the engineer. So the engineer is the one that's going to approve everything. If you need some kind of request for RFC, request for change, or a design change, or something isn't working, the approval's got to go through the engineer. The contractor can't approve it. It's got to go to the engineer or the authority having jurisdiction, whatever that might be. Maybe it's, you know, some kind of governmental organization or whatever. But once again, we see the engineer pop up here. The engineer has to approve a lot of things. Design of welded connections. I'm going to tell you, I am not a structural engineer. I don't operate in clause 2 very often, so I'm just going to read through a couple of slides. We'll call it good. If you need more on the structural design side of how things work, I'm not your guy. I do welding, but I don't do structural design. My apologies. 2.1, scope. This clause covers the requirements for design of welded connections. It is divided into 3 parts as follows. It's divided into, it used to be 4 parts, but now it's 3 parts because I think they took a bunch of material from here and stuck it in clause 9 with all the tubular design connections. So part A is common requirements for design of welded connections, non-tubular and tubular members. Part B is specific requirements for design of non-tubular connections, statically and cyclically loaded. The requirements shall apply in addition to the requirements of Part A. Part C, specific requirements for design of non-tubular connections, cyclically loaded. When applicable, requirements shall apply in addition to the requirements of Part A and Part B. So this is just telling you what this covers. Contract plans and specifications. 2.3.1, plan and drawing information. Complete information regarding base metal specification designation, location, type, size, and extent of all welds shall be clearly shown on the contract plans and specifications, hereinafter referred to as the contract documents. If the engineer requires specific welds to be formed in the field, they shall be designated in the contract documents. The fabrication and erection drawings, hereinafter referred to as the shop drawings, shall clearly distinguish between shop and field welds. So this is telling us, you know, hey, if you're the engineer and you're putting together the contract documents, you need to tell us the base metal specifications, location, type, size, and extent of all welds. That all needs to be shown clearly. You can't just throw it to the contractor and say, hey, go cobble this together. You do your best. You need to have the site and the size and extent of the welds listed in the documents, contract documents. If the engineer wants specific welds to be done in the field, let's say we're building some big structure and we can't get it on a truck and it's got to be done in the field, he needs to tell us, or she. The engineer needs to tell us what the location is of those field welds, and they need to call it out. There's a little weld symbol up there. The little triangle guy tells us that that's a field weld. So the engineer really needs to tell us between shop and field welds. And this is pretty much about all I'm going to cover on Clause 2, because the rest of it's math and structural engineering related stuff, and not my area of expertise. Summary. Okay, what do we cover in this PowerPoint presentation or this little YouTube video? We talked about the scope of D1.1. The limitations of it. The scope and limitations tie together. Okay, D1.1 is for structural applications. We don't do power piping, we don't do boilers, we don't do rebar, we don't do aluminum, we don't do titanium, we do low carbon and carbon structural steels for structure. We don't do rebar, we don't do bridges, we don't do sheet steel, we don't do stainless steel. This is what this code is. And that's all laid out in the scope and limitations. Under definitions, we talked about engineer, who the engineer is, how much power the engineer has, what the engineer can do. The engineer's got a lot of power. The engineer can add or subtract things from the code as long as they keep track of it and document it and put it in the contract documents. The words shall, should, and may. We discussed shall. Shall means you are going to do it. There is no vote. There is no getting around it. Shall. You are going to do this. Unless the engineer says no, then you can get out of it. But if it's in there, you have to do it. Should. Should is a best practice. Should is a little less harsh than shall. Should is, this would be a really, really good idea if you could do it, but if you don't, it's not the end of the world. And may is a few options that you may do this or you may not. And if you don't, we're not going to cry about it. And if you do it, fantastic. But may is one of those words where it kind of gives you some room. I had an instructor that always called these wiggle words, gives you a little wiggle room. Should, may. We talked about responsibilities, the engineer's responsibilities, the contractor's responsibilities. The contractor is in charge of, qualifying the WPS. That's not the engineer's job. The contractor does that. The contractor's in charge of, following the rules and getting the contractor's inspection done. We talked about approval. Then we talked very briefly about design of welded connections and contract plans and specifications and what needs to go on contract plans and specifications. So that was what we covered in this little YouTube jaunt through D1.1. The next one I'm going to cover is pre-qualification of weld procedures, and it'll probably be a standalone where I talk about pre-qualifications because that one gets pretty messy. But anyways, everybody have a good day and enjoy. Any questions, comments, you guys know how to get a hold of me. There's my website. My name's Gary Pace. I'm a CWI and a professional engineer. My focus is on welding. So if you got any questions, I know some of you have sent me texts or emails and asked questions. So feel free to do that. Sometimes I might not get back to you very quickly, but I will get back to you. All right. Take care. Have a nice day.